Let's talk about the LeetCode 2276 counter integers in interval. For this question, it lets us to implement a data structure to store those kind of intervals. And for every, it need us to implement two methods. One is add, another is count. Add will add an interval to the intervals. Count will count the numbers of integers that are present at least one interval. So this interval, they are left and right inclusive. And we know, of course, we can brute force to add left and right, and count those kind of numbers. Um, the things that let's look at the data range. You'll see that the interval, those kind of number, left and right, it is small greater equal to 1 and small equal to 10 to the 10 to the power 9. So this number is very big, right? So we cannot go through this kind of use for some diff array to go through those kind of numbers, right? Because that will be too big a number. So what we think about is that you say that at most 10 to the power 5 call in total will be made to add and count. So the thing is that we need, we will say we are at most at 10 to the power 5 intervals. So the interval itself can not be greater than 10 to the power 5. So we thinking about this 10 to the power 5, right? We can use some kind of n log n approach. So intuitively, what we're thinking about is that we can use some kind of tree map data structure. So for tree map, what we store, for example, there is an interval, right? The tree map, the key will be an integer, will be a start of an interval, and the value will be the end of an interval. So initially, what we want to do is that we add left right because this is empty, right? We just put a new entry to this tree map. And when we add, right, add a new interval to this data structure, for example, our tree map already store those kind of intervals, right? So when we add a new entry, what happened is that um, is that we may, for example, we add a new entry like this, right? So this being the most optimistic way is that there is no overlap, right? Then we just need to add a new entry to our tree map. But it's possible this kind of entry, for example, it is covered by some kind of entry, right? Or this kind of entry, for example, it have overlap with some kind of other entries. Or even worse, this entry has a lot of overlaps with some of the previous entries, right? So what we're thinking about is that we should do intervals merges, right? So what we can do is that for the new entry we add to this kind of map, we find it's right? We find the floor key of the right point. For example, we find that this floor key is here, right? So you can see that means this kind of interval has start greater than our has overlap, right, with our insert. We'll say find its floor key. It's not necessary have overlap. It's possible it has overlap. So if this floor key, for example, the floor entry, the value is smaller than our left, right? There is no overlap. But if the value is greater than our left, then that means it has overlap, right? So what we need to do is that we keeping remove those kind of overlaps, right? So so our left will be the minimum of this one and this one, right? And our right will be our right and then the maximum of the this kind of overlapped interval, right? So until we find its flow entry do not have overlap, the value is smaller than our left, right? Or if there is no flow entry, that means there is no smaller um, uh, intervals which has start is less than our end, right? So there is no until we get rid of all of the overlaps. So during we get rid of the overlap, we can do we can use another variable called total counts to maintain the numbers, right? So we get rid of these intervals. We get rid of uh, the old counts, right? Until we are able to add the new updated interval to our tree map. We are going to add the total counts from this kind of new right to this kind of new left to the total counts. We also, because this interval does have interval with does not have intercept with other intervals, we are able to insert to our tree map. And doing like this way, because there is conditions at most 10 to the power 5 calls in total will be made to add and then counts, right? So that means if we add 10 to the power 5, right? If there is for every add, there is let's look thinking about the extreme cases. Every time we add, there is no overlap, right? So we don't need to get rid of those kind of intercept, right? So the counts is just add 10 to the power 5. So counts is also so this kind of if we trim up, that is 10 to the power 5 log 10 to the power 5, right? But if we add, there are a lot of intercept, right? The good thing is that for those kind of intercept, we get rid of those kind of overlaps to merge that into one intercept. So let's think about another extreme cases is that, for example, every time we insert, there is intercept, right? So in the end, it only left one intervals because every time there is intercept, right? So in any cases, it will not exceed those kind of n log n approach, right? So after this analysis, let's write code for this, right? We have int total count equals 0, and we need a tree map for the intervals. For this tree map, the start will be the key will be a start of an interval, and the values will be the end of our interval. So I'm going to have intervals equals new tree map. So for our when we insert high left right, what we do is that while true, as long as we're keeping trying to see whether there is any intercept with existing entries in our tree map. So we can have map dot entry integer entry equals intervals flow entry dot right. So we'll say if this entry equals none, that means there is no entries in the map, no intervals which have the start is smaller than current insert right. Or we'll see entry dot get value, right? If this get value is smaller than left, that means if there is a smaller interval, but there is no intercept, then we can break. Otherwise, we're trying um, to get rid of the older entries. So we're going to have int start equals that is entry get key, right? That is in our data structure. We have such an interval we inserted before, right? And equals entry dot get value. And what we do is that we're going to have left equals max dot mean left and the start, and right equals max dot max right and end, right? So in this case, we need to get rid of the older entry. So get rid of the older entry, we need to update two things. One is the total count, right? Total count should minus equal to and minus start plus one, right? And also the tree map intervals, we should delete, remove those kind of older entries, right? So then we can insert this left can already been updated, right? That is merged left. This right is merged right. So we can add new intervals to our data structure. To add new intervals to our data structure, we also need to update two things. One is the tree map, put left, right, right, and also the total count. The plus equal to right, because that means that when we do this kind of update, this kind of left and right have no overlap with other intervals. So we can just add equal to right minus left plus one. So what we return is total count. And let's also have the Python code as well. So we because we needed a sorted dict, right? So we from sorted containers import sorted dict, right? So we define two self dot total count equals 0, and also self dot intervals equals sorted dict. So when we add, what we do is that while true, we need to have get the entry, right? Entry equals self dot intervals bisect right minus one. So if entry is smaller than 0 or self dot intervals pick item entry one, right? Has no intercept, then we can break. So then we're going to have get those kind of entries, intervals in the or entries in the tree map which have intercept with current start left and right, right? With self dot intervals pick item entry. So we're going to have left equals mean left and start, and right equals max right and right. And we are going to remove the old entry. We do two things: total count should minus equal to and minus start plus one, right? And also we should delete self dot intervals start. And after we delete the overlapping intervals or entries, we need to add this kind of new one, right? Self dot interval dot left equals right, and the self dot total count equals should plus equal to right, plus equal to right minus left plus one. For this count, just return self dot total count, right? Okay. So the time complexity as we per se, because this one, right? This one, this add, it is a log approach. The optimal cases for this add is there is no overlap, so it will be a log n operation, right? But if there is overlap, for example, there is k overlap, so that will be uh, there will be we should get rid of this while loop, right? K log an operation, right? But if there is overlap, that means we get rid of the entries, right? That means that entry gets smaller. So next time we're doing we need to check less intervals. And so the worst case is for this one is an log n approach. The space is ON, right? Because we put it, the worst case that, for example, we add n entries. They all put on the tree map. So time complexity was it n log n time complexity space ON space complexity.